Find the force in member CD in kilonewtons. In this problem, a truss is subjected to a 60 kilonewton force downward at joint F and subjected to a 20 kilonewton force to the right at joint B. Externally, the truss is connected with a pin connection at joint A and a roller connection at joint E. The dimensions of the truss are also provided. The force in member CD can be determined by cutting an imaginary section through members CD, DG, and FG, summing the moments at point G, setting the value to 0, and solving for the force in member CD. This equation assumes member CD experiences a tensile force. Currently, the unknown variables in this equation include the length of member DG, the vertical force at joint E, and the angle theta, made by members CD and DG. To solve for the vertical force at joint E, we'll sum the moments about joint A, which includes the 20 kilonewton force at joint B, the 60 kilonewton force at joint F, and the vertical reaction force at the roller connection at joint E. Solving for the vertical force at joint E, we're left without knowing the angle phi or the distances between joints A and B, A and E, and A and F. The length of member AB equals the square root of 74 meters. The length of joint A to joint E equals 20 meters, and the length from joint A to joint F equals 15 meters. The angle phi is calculated by taking the arctangent of 5 meters divided by 7 meters, which equals 35.5 degrees. Plugging in the angle, the lengths, and the forces, the vertical reaction force at joint E equals 52 kilonewtons, and we can add this value to the figure. Returning to the section we cut earlier, we can plug in the value of 52 kilonewtons for the vertical reaction at joint E. The other two unknown variables needed to solve for the force in member CD are the length of member DG and the angle theta. The length of member DG is the same hypotenuse we previously calculated, the square root of 74 meters. To find the angle theta, we'll extract the triangle CDG from the truss and define angles theta 1 and theta 2, which makes theta equal to theta 1 plus theta 2. From the given dimensions of the truss, theta 1 equals the arctangent of 2 meters divided by 5 meters, or 21.8 degrees. Likewise, theta 2 equals the arctangent of 7 meters divided by 5 meters, which equals 54.5 degrees. Adding the values of theta 1 and theta 2, theta equals 76.3 degrees. From observation, the length of member FG equals 5 meters, and the length between joints E and G equals 10 meters. Plugging these values into our equation, the tensile force in member CD equals negative 26.3 kilonewtons in tension, which is equivalent to a compressive force of 26.3 kilonewtons. When reviewing the possible solutions, the answer is D.